Okay, how do we find the surface area generated by this curve y is equals to gx from the point a comma 0 to the point b comma fb. So basically what will happen is that this piece of shaded area is going to rotate about the x-axis 360 degree to form somewhat like a bowl, and we are asked to find the surface area of this bowl. Now to make things simpler, let me erase all this drawing and this shaded area. Now what we're going to do is similar to what we have done earlier. We are going to divide the area bounded by the curve into strips. Okay, and each of these strips are going to have the same thickness, small change in x. And we already know that all we have to do is to consider one of the strips, rotate it about the x-axis, and we will get something like a part of a circular cone, okay, where this length over here is a small change in s, which represents a small change in the arc length, and this top part of the circular base would have a radius 1, and the bottom will have radius r2. But if we consider our small change in x to be very small, close to 0, then our small change in s is also very small, which will make R1 and R2 almost the same. Alright, and from the diagram we can tell that in this case, when R1 and R2 is almost the same, basically the value corresponds to our y value, right? Now, but you have to be careful. If you look at this y value is negative because it's below the x-axis. So if you want to say that, oh, the radius is y, it is not correct, because the radius should be negative y. So if I want to find the surface area of this piece of partial cone, okay, that is generated by this strip being rotated 360 degree about the x-axis, the surface area generated should be 2 pi r. In this case, my r is minus y, not y, minus y, because this value that you're reading off is actually a negative value, and L in this case is still your small change in S. Okay, and as mentioned, small change in S in the arc length video, we can rewrite it as square root of 1 plus small change in y over small change in x whole thing square small change in x. Now, but this is only the surface area of one of the strip, okay, being rotated about the x-axis 360 degree. Now, I need to sum up for all the strips. So the surface area we're looking at in this case is going to be the sum of all these strips. So 2 pi minus y square root 1 plus small change in y, small change in x, whole thing square, small change in x. And this will not be accurate unless I have set my small change in x to tends to 0. So meaning I'm finding the limit of this sum when my small change in x tends to 0, which is equivalent to integrating 2 pi minus y square root 1 plus dy dx whole thing square dx, and since I'm integrating with respect to x, I should be looking at the x value, so from a to b. So notice that when we consider the curve that is below the x-axis, we have to be careful. Okay, it should not be a y, but rather it should be a minus y. Okay, so that is something that you should take note of.